Hi and welcome back to my channel. In this video I want to talk about race conditions and how that can affect your applications. So here I have an array of 1,000 numbers and I have two functions, is odd, is even. I run these two functions in parallel using TPL program in .NET, and I have a count field. Each time I detect an even number, I increase the count value, and for odd numbers I decrease. And what we expect here is we at the end of the application, when we right line the count value, it should be 0 because half of the numbers in this array are odd and half other is even. So let's run the application. Okay, that was fast. The count is 0 and everything is just fine. So let's go back to our application, and instead of 1,000 numbers, let's do 1,000,000. And this underscore is a functionality in C#7 or later, I guess, that you can separate zeros or values in numbers for better readability, and I like it. So I'm going to run the same application for an array of 1,000,000 numbers. Let's see the results. This time the count is surprisingly not even close to 0. We have 15,000. Let's run the application again, and again we are far off. Let's do it for the third time, and now we are even more off. So what has happened? Actually, this is what race condition means. So the problem we are facing here is race condition. We are running two functions in parallel, and we are accessing a shared resource. And when that happens, it's very hard to synchronize change that happened to the shared resource. So when one is adding, one is removing, the same value maybe gets checked and changed, and as a result you see that we don't get to 0. So this diagram could help to understand race condition better. We have two threads and a shared memory, which is in our application is the is odd, is even, and count. And I'm showing count in this diagram with C because it's shorter and easier to read. So at one point in time in our application, when thread 2 reads the memory, the value of shared memory, the value of count is 12. And thread 2 wants to add one value to it and reaches to the fact that the value of count should be 13. But at the same time on thread 1, when thread 1 reaches the memory, it realizes that the value is 12, so wants to decrease one number and reaches to the fact that the value of C should be 11. And at the end of the process, when we reach here, what we have in memory is 11. We were expecting to reach to 12 at the end of time, but because we are in a parallel situation and the memory is shared, it is undetermined that which thread is accessing memory first and which one is writing to it. So this is just chaos, and you cannot really predict how threading works in these kind of situations. Of course, there are many ways to solve this problem. In this video, I'm just showing you what is the problem. So one quick way to fix this problem here is to use interlocked. I remove this line and use interlocked. We need to add a threading using and use decrement and reference the count value and we can use the same for this one, increment this time, and let's save and run the application again. So this time the value of count is 0, and you can repeat this again and again and the result will be the same. So we fix the problem of race condition in this case by using interlocked. This is only one way that you can solve the problem, and interlocked is very limited. There are very few conditions that you can use this tool in threading, but it works at least in our case, and that's a beginning to understand how to solve a race condition. So how interlocked is working? Interlocked has a few functions, and basically it is reaching into the CPU instructions and running the operation here in an atomic way, making sure that the shared memory is not shared anymore. And that's how it is solving the problem for our application. As a .NET developer, you don't really need to know what is happening behind the scene for interlocked. The most important thing is that interlocked can solve some race condition problems, and for others you need to just reach into other tools in TPL, and that's something I would love to talk about in future videos. Thanks for watching and see you soon.